today we have a new topic to discuss, and this is all about theorems of differentiation of algebraic functions in higher order. As you can see, this topic is quite long, so all we have to do is to discuss first with theorems of differentiation of algebraic functions. Now recall, in the previous topic, we were able to find the derivative using its definition. And for those who are not able to see and watch the video, so you can visit this link by pressing it. Okay, now what's the problem of using these two formula? The problem is, as the function becomes complicated, our solution becomes also complicated because it involves h. So all we have to do is to find another way to find the derivative that is easier compared to these two formula. So I give you here the basic derivative rules. First is the constant rule. The constant rule says that the derivative of the constant is equal to 0. So for example, if the given is a constant function, let's say f of x is equal to 4, then the derivative of 4 is 0. Then the next one is the constant multiple rule. This is used if we have a function like this. We are given a constant times a function. So all we have to do is to find the derivative. You copy the constant, then multiply by the derivative of f of x. Don't worry because I'll give you an example for each of these basic derivative rule. Now the next one is power rule. The power rule can be used if we are given the function of this form, x raised to n. So what is the derivative of x raised to n? This is equal to n, okay, n times x raised to n minus 1. So for example, what is the derivative of x squared? The derivative of that, since 2 is the exponent, you just simply copy 2 times x raised to 2 minus 1. So that is 2x. The next one is sum rule. Sum rule is used if we are asked to find the derivative of the sum of two functions. Then the derivative of that is equal to f prime of x plus g prime of x. This means that the derivative of the sum of the two functions is equal to the sum of the derivative of each function. Then the difference rule is the same as the sum rule. The derivative of the difference of two functions, f of x minus g of x, is equal to f prime of x minus g prime of x. This means the derivative of the difference of two functions is equal to the difference of the derivative of each function. Well, the product rule can be used if we are given product of two functions, let's say of the form f of x times g of x. Then all we have to do is to use this formula, that is f of x times g prime of x, meaning you copy the first function times the derivative of the second plus g of x times the derivative of the first function. So what's the technique here is to familiarize this formula. Then the next one is the quotient rule. The quotient rule is used if we are asked to find the derivative of the quotient of two functions. Let's say f of x over g of x. So we have a mnemonic device to remember this formula. First is you look at the denominator. So the denominator is g of x. Then you square that denominator, okay? Then for the numerator, you copy the denominator, g of x, times the derivative of the numerator minus the numerator f of x times the derivative of the denominator, okay? So again, you have to familiarize the formula. Then the last one is the chain rule. The chain rule is used if you are given a composite functions. So the derivative of f of g of x is simply equal to the derivative of f at g of x times the derivative of g of x. Okay? G of x is a function that is inside of another function. Okay? So to understand more on the basic derivative rules, we have these examples. Okay, find the derivative of the following function and state what theorem being used. Number one, This is an example of a constant function. We're given f of x is equal to 3, then by constant function rule, since 3 is constant, then the derivative of that function is 0. Number 2, if you are given f of x is equal to 3x, then the derivative f prime of x is equal to constant times the derivative of x. Okay, this is the notation of finding the derivative. So 3 times the derivative of x with respect to x. The derivative of x is 1, therefore is equal to 3 times 1, which is equal to 3. This is by applying constant multiple rule. Or another notation, the derivative of f of x, where f of x is this, is simply still equal to this. 3 times f prime of x. F prime of x is 1, so is equal to 3 times 1, which is equal to 3. Then the third example is equal to f of x is equal to x raised to 4. This is what? A power function. Okay? Now, by power rule, this is equal to f prime of x is equal to, you copy the exponent 4, then multiply to x raised to the exponent 4 minus 1. So this is equal to 4 times x cubed by applying the power rule. Or in other notation, the derivative of f of x with respect to x is equal to the derivative of x raised to 4 with respect to x is equal to 4 times x raised to 4 minus 1 is equal to 4x cubed. Still the same answer. Then the fourth one is sum rule. So sum rule because we are asked to find the derivative of the sum of these two terms, x and 1. So all we have to do is to get the derivative of each term that is equal to the derivative of x with respect to x plus the derivative of 1 with respect to x. Now, the derivative of x is 1 plus the derivative of 1 which is constant is 0. Therefore, 1 plus 0 is 1. That is by applying the sum rule. The third one and the last one is the difference rule. That is getting the derivative of the difference of these two terms. We have the derivative of x minus 1. You get the derivative of x minus the derivative of 1, which is equal to, this is 1, minus the derivative of 1. This is minus. This is minus. So 1 minus 0 is equal to 1. Okay? And that's it for now. So, for more examples, next examples will be product rule, quotient rule, and chain rule. So, stay tuned for next videos, for next examples regarding the product rule, quotient rule, and chain rule. Hope you like this video and you learned from this video. Keep on sharing what you learned from this video. Thank you and God bless.